All right, cool. Welcome back. Another week, another step into computational mechanics. Do you have senior design? I know there's a lot of seniors. Do you have your projects assigned yet? Cool, nice. If you like this material, well, even if you don't like it, I would highly encourage you to try to like organize your data in like either Python. I mean, if you prefer MATLAB is fine, but Python and Jupyter notebooks, they make a great way to organize like data, models, and also like references and thought process. That's what I like about these Jupyter notebooks, is that it helps me organize like all the research that I'm doing and like the things that I'm trying to get to. So what I want, or what's been done, what I'm doing, and then kind of wrapping up whatever conclusions I have. So I would highly encourage you that rather than trying to put all your data into disorganized Excel files, because sooner or later they get all disorganized and bloated and hard to read. Jupyter, Pandas, all these are like great tools that you can try to use. Anyway, that was my quick plug for use what you're learning in the class to help everyone, help yourself get to results quicker. What are we working on today? Anything break or issue? Yeah. Oh, with time it? Yeah. Just like how to do it, or okay. All right, let's try timing it then. So let's see. All right, so the first thing we're trying to do is like, I think A99 is the first time that we're trying to like time it. I'm gonna zoom out a little bit, then I'll zoom back in. There we go. Just so I can see a little bit more. So time it is a great tool whenever you're trying to figure out like computer resources, like how long does it take for the computer to do something. It's not like something that you can just throw in and use all the time. Like you have to keep things like apples to apples comparison of like, if I make a small change here, how does that change like how long it took the computer to do something. How did people make A99 this with like for loops here? What did you do? Let me check in. I'll see what people did. Then we'll do a comparison between like, because in this case, if I have two arrays x and y, I can just say A99 is x times y, and then I'm done. Like I've gone through the for loops and all that. But I want to know how you did it without NumPy. Did you create like I have not gotten there. I'm still on it before that. Yeah. Did you try creating that A99? Sine, cosine, cosine. Yeah, Nolan, I can go back to sine, cosine. Some of the people are working on that too. All right, so what I saw was a lot of people did something like this, where you say, you create a whole bunch, you create an array that has ij parts to it, and then fill that array up one at a time. So here I'm just calling it zeros. You could use empty, but for I in range 10, for j in range 10. Times j, something like this. At least that's what I saw. And this is kind of like standard programming practice of like, I want to go one loop through this and then one loop through another, and this works. It'll work great. The key is that you need to initialize. This is called initializing, and just like telling Python A99 is going to be an array, and it's going to have 100 values laid out in this structure. But another thing that we could do is called list comprehension. Have you heard that term before? This is like the Python way to do things, is list comprehension. So get rid of all this. I'm gonna have two nested lists, and then say that it's I times j. And then I can, within that list, so I'm creating like a list that has for loops inside of it. For I in range 10, for j in range 10. And I took those, and it wasn't long, like I had 4 lines of code, but I turned it all into like 1 or 2 lines, just kind of, I don't know if it really simplifies things, but this is very Python specific, that you can do this. You can put a loop inside of a list, and then it creates a list of whatever that loop was. It can be super helpful for like dealing with weird data, like you want to you want to go through each piece of the data and save it if it's one thing and throw it out if it's something else. So list comprehensions are good for that. Or in this case, like we have some kind of function that we want to do, and we should double check that it gives us what we want. Oh, too far. There we go. And sure enough, it's like the multiplication tables with zeros all the way up to like 9 times 9, 9 times 8. It is giving me what I was looking for. All right, so now I want to know how long this took. And I just want to know how long it takes to do this operation, like these two nested for loops. So don't put print statements in there. Don't add like import functions. If you're using time it, the first line is time it, and then whatever's inside the cell, that's what's getting timed. So it'll take a second, because now it's going to run through it maybe 1,000 times and give you an average. Like this took 8.6 microseconds for the computer to do this, versus, let's just look at this one. So comparing like 2 loops versus x times y, this one took half a microsecond and that one took 8.6 microseconds. So roughly like 10 times longer, something like that. But that's how you use that time it. Is the kind of couple of things is like it has to be on the top of your cell that you're using, and then whatever's inside that cell is getting timed. So if you have anything like import or a plot statement or a print statement, all that is also getting timed, but it's not telling you like the computer operation, like the creating A99 or like taking the mean or the standard deviation of it. Like if we wanted to add that, we could. And really, it's just kind of like adding time to both of them, right? Like it's not changing how long it took to do this operation or that first set of for loops, but now we're starting to time how long it takes to call these functions and run that mean and standard deviation. And both of them, like I think it added 36 microseconds to both of them, right? Roughly like 30, 40 microseconds. Does that help for like using like mechanics of how to use it a little bit? Yeah. So again, super useful tool. The caveat to this is that if your code is working and it's doing what you want it to, then like that's great. If it's taking half of a microsecond versus 4 microseconds, that's, I mean, a drop in the bucket of your life as an engineer. Is it worth going back and refactoring code to like optimize it? If you like that stuff, then yeah, totally. Like if it brings you joy, then then go back and get things to go faster. This is a tool, like specifically here, that if you can think about doing things as vector operations rather than vectors and arrays, then it's always going to be faster than doing things inside of for loops. Sometimes some codes are different. Like if you're using C, it doesn't matter whether you use an array or a for loop. But for Python specifically, if you can, stick to arrays. Okay, so other thing that some people were working on and then Nolan was asking about is in this sine cosine. So when I'm trying to create a function, usually I start by just running some things of seeing like how does it work? What do I want it to do? What do I want as an input? What do I want as an output? Here, everything's kind of set up for you. Like I kind of gave you a roadmap of this is your input, this is your output. But if I have an input like x that goes from 0 to 2 times pi, then I want like sine x to be sine of x and cosine x. Or sine, I could call it sin and cos. And I can double check that this is giving me, whoop, where are we going? So I'm getting a sine, I'm getting a cosine, looks like what I want. Now I can turn this into, rather than having just a step-by-step kind of, what am I thinking of? So take this script and turn it into a function that I could reuse. So the main meat of my function is this sx and cx. So I'm going to tab that over and write def sin cos of x is now going to be, and Python is tab based. So whenever you have tabs, it's expecting it to either be part of a for loop or part of a function, something. So because those are tabbed over, anytime I run that function, it's going to do those 2 steps. But I need one more thing to get it to give me output. Do you know what that is? Yeah, the return. In MATLAB, I think you would put it like up here, like sin x and cos x equals that. But here we say we return the stuff that we want. Return that sx and cx. And I'm gonna restart. Because I just want to show you an error that's gonna come up. Well, I think there's going to be an error. Do you think there's going to be an error? Yeah? Why is that? It didn't work, yeah.
Isn't it returning a tuple right now instead of two arrays? They can't call the correct function.
Kind of, yeah. Sorry? You have to call the function. So we actually, when we define the function, it defines it, but it doesn't actually run it. So that DEF statement is creating a variable called sin cost, but it hasn't done anything until we actually say sin cost of X. And here, I'm going to change this to like Y1, Y2. Oh. And yeah. So if you tried to run it, you probably got same, there we go. Same error, like something to this, like a name error that it's not defined. Because if you haven't actually run that function, then you haven't assigned the thing that the function did to a variable. And that's like the missing piece. Versus, things moving slow. It is Friday morning, right? Maybe my computer was up on Thirsty Thursday. There we go. Okay. So now I define the function, run the function, use that output to actually plot the variables, something like that. All right, last step is being a friend to future Professor Cooper, or future you, like as the person that's most likely to run this code later is you. So be nice to yourself and like give yourself some helpful hints of like, this is what this is supposed to do. If you know that it doesn't work for certain things, then tell yourself like, this isn't gonna work if you do some X so-and-so or something like that. Put 3 like triple quotes, and now we can create what's called the doc string for that function. And oh my god, both the sine and cosine of an input of X. Arguments. This is usually like a good way to start of like, what's the input, what's the output, and that's usually a good starting point for how you document like what your function is going to do. You can put anything in here. You could write Batman 63 times, and it's not going to change how the function runs. But the next time you ask for help on this function, it's just going to write Batman, Batman, Batman. So when I'm looking for help, it's like, all right, I know this function exists, but I don't remember how to use it. This question mark, sin cost, like the question mark, and then whatever function you're trying to use, it prints out exactly whatever's in that doc string, and that's why it's good practice to define like some kind of doc string, like what is this thing supposed to do. And then even tells you like where it's from. But that's why I'm telling you, like, make a doc string. Again, it's just being civil with your future self. It's like, hey, remember when we wrote this together and the input was supposed to be an array, but you're giving it, like, I don't know, an entire like CSV file, and it's not going to work. So turn that CSV into an array, then dump it in there, and now it'll work. Cool. Nice. That was a good start. Were there other things that had come up so far? I'll check in, see what people are up to now.
So going to the A99 problem,
Yeah.
when you're doing the mean and standard deviation, why is it only outputting, let's say, standard deviation here? It's just more of a rule of Python.
That one is
It's just taking the last.
Yeah, exactly. So for these cells, because each cell is like a block of code, and the only thing is that gets printed out, the only output is whatever is actually. Yeah. So you can tell it print or
They print the last one.
yes.
Okay.
Well,
If it's
actually,
printable.
key places study. If you use an actual print system, then it's a print area.
Yes. Okay, that makes sense. I was confused. I had print statements in, so it was doing everything, but taking them away, it only did.
Yeah, exactly.
That makes sense.
So those are you can either do that, always use a print statement, or everything that you want to see give it its own cells.
But in terms now to do the time that page, don't include print statements because that's just going to bump up the time.
Yeah, exactly. Yeah, for time it just you're just trying to find like apples to apples comparison. So that might be its own like mini cell or something. Did it give you an error? Oh, an indent error. Oh, I see. On that first line where you have just give that an indent. Yeah, it was bad. Now, because in general, no matter what you put in there, it shouldn't matter. The more helpful you are, the better, but as long as it has three. Oh, yeah.
Yeah. So I'm doing well today.
Yeah.
And
Homework too.
Yeah.
Trying to get ahead.
Yes.
Sweet.
And it says it's a bonus. Oh, so what is the bonus? Or is it just like a fun activity to try?
Oh, you mean like how many points do you get?
Yeah.
Oh, it's just it doesn't matter. Yeah, it's just like if you want to challenge yourself. Yeah. It's like my kids call it earbuds. It's worth like 50 earbuds.
Okay, so I'm gonna picture your voice.
Yeah.
Okay, perfect. That'll be good.
And all the prize points.
Yeah, I need to find points.
Yeah,
I'm gonna do it.
exactly.
Yeah.
But again, like if it works, it works. Still kind of coming back to like the basics. You know, if you're getting results that look right and feel right, then that's more important than refactoring everything.
There was more like 3,000 things there, probably.
Okay. Yeah. Nice. We're gonna try like the list comprehension or nested. Okay. Yeah. That's usually like the standard computer science approach. The list comprehension is like the working Python way.
Yeah.
It's kind of cool.
So now, Yeah, it looks like you're doing all steps that you want the function to do. It's just that you're doing it in a form of easier. But right now, it works like that first Greek quote string that you created. It's not saved anywhere. It's just yeah, like it's not assigned to a variable.
So you just didn't define it.
What do you mean with you? What is the calculate flow there?
No, this part, you see, said it was an error, that's,
Okay.
So
These.
yeah, it's because you defined your variable here with because it was the time it was making up.
that's why, someone will solve it.
I am salty actually. Thank you very much for noticing.
My whole place there is making you those notes.
Thank you. I feel noticed. Thank you. I did not forget your name. I'm trying to come up with something silly to say, but this didn't work. You just called me? You called me Alex?
Yeah, what's up, Alex?
Bro, bug with my name? How dare you, Alex?
Yeah, you do.
I thought we had something.
What was leading to do?
Part probably is. I've never felt so alone in my life. The guy, yeah, like Genghis Khan. Probably understand.
You don't even have to do words. There's something variable and other second that was well. Yeah.
Oh, how do you build content?
Yeah, it takes longer.
You do the create a full content.
Because I agree.
Oh, no, he's not. Bro, I use the term of they say nowadays.
Yo, look at this. This one, look at this color. Which one?
Oh, that's kind of the easy part of that third part. Yo, Alex over there.
Look at what this function is called. I didn't even.
No,
They're already.
It's on digital?
Actually, higher than they are raised.
I hope so.
You just want to A99. It's just simple. They're already raised, so you don't have to. You have to put in there.
Why is this wizard is the not array map or anything? Is this supposed to be quicker? Okay, we're good. Days of chilling for days in.
And so there's still part of your work. It's called the namespace.
How do you do the field combo plot?
Oh, not a problem.
You're working on it?
I didn't see that part. I really sure for now. Oh, top of that. Wool. Oh, the plot with code.
You have to PLT dot.
Just how much you work now?
PLT dot contour.
Not really.
Well, you can use bracket 0 and bracket 1 if you want to watch it.
Z is A99.
Yeah.
I don't know what the level is.
Okay, where's two? So you don't know what you do.
Yeah.
PLT dot contour.
Did you get a word? Hey Jeff, did you get a word?
Yes, I was earlier.
Wait, what did you do?
I always the PLT dot contour and put X, Y, A99.
All in the same thing?
Yeah.
I mean, if you want to keep it over that's great.
Those busting it up. You're back contour.
So this is not work.
So I know. The highway. The highway. I'm like, you're stupid. It's just that. Did you import maps off of that? Put it in different, make it Excel and plug in that.
Yeah, actually.
Do you still have shopping? We allow him to write the shopping. What's our space over there? We got,
Oh, that was like
yeah, we can build next door.
you still would love that. Right? And last year, so
No, he does not still bang.
I'm gonna bang on my couch.
And then he just started banging all over the place.
He's got a corner couch. That's one of the awesome spots. Dude, good couch. Dude, food couches. They got two couches for reception. I got this. Really the whole wall. It's really the whole wall.
Oh, do you think it's for me? You have to rank the variables of the meetings and print them in a different thing than you do something and then do this.
Okay, yeah.
I know, it's like, yes, that's cool. I would, when I would do that, biggest mistake.
Which team did you get hired?
I got the. I got tired.
Oh, the year one?
Each one of these columns. Colors are
My house.
represented in a scale.
We have a dock now. So if you want fish over there,
Oh my goodness, I was like fishing either town.
you can't go on my property though. Stay in the public lake. Could it it's a state remote out of state? No, it's actually not like it. It's a razor. I know it's not. It's state. Is it like
So I can't fish in the property? You want to be fishing license? You don't have to be a fishing license?
Yeah.
Can't fish from the property. I'm going to start doing it. I'm just gonna set up a little, so maybe those things.
Fishing pole?
No, you catch a fish, you put it in your nose, and once it sits in the water still. That's how they. It's not, it's only, so it's still, it's your fish don't die.
Oh, I know what you're talking about. I get some
I want to do also a trap. Because the water does not run fast enough. I'm gonna do that like your fish spot. I would just all besides fish and say you catch it. Report it.
Make sure you're not fishing for trout with any excess weight in it. You're not, if you're using a lure, you can't have any sinkers.
Oh, really?
No, if you're
I did not think I should have lost. That's what happened.
no, that's it.
Oh, so did yours work or no? The old pizza deal. Why?
Yeah, that's a time extension. Yeah, it's really good time. You're not allowed to shoot you. And you have later this might be a copy your key. Thank you for the question. I'll take a picture of you. I think the contour plot to be all solid color. Excuse me. How do you get the contour plots in solid color?
Just contour F.
Contour F?
Yeah.
Oh, really? Wow, it is that easy. Thank you.
Yes.
what do people get about this? This is my cookie painting. This is the final clause. Consent.
What do you mean those images? Why you gotta say it like that? It's only the time of year.
There's a lot going on here. Not really. This one.
Yeah. I think so.
We have to obviously define if you want. So what do you want to call it? Okay, value of this. Mine is 1.5. I'm gonna make mine 0, 0, and 1. Should go on. Did you solve it? What's X? What is the value for X?
Sorry, I'm coming back. Looking at contour plot issues. Oh, that's down here. Okay, cool.
What's the freaking syntax?
So as long as like X and Y are both so if X and Y are both so there's a question about like how to do this contour plot, contour F. And I'll see if I can recreate the error. So in the levels, input Z must be 2D and not 3D. And that is true. Like we can't have a three-dimensional array as part of contour F. But I'm trying to think of how it might have gotten to a 3D array. I don't know. Yeah, so you can manually put in the levels like Nolan was saying. Oh, and in the so if you're looking at like, all right. Yeah, let's look at the documentation for contour F. In documentation, it tells you like bracket XY. The bracket is telling you that's optional inputs. So if you just say contour F A99, you'll get a plot. But if you want to tell it, put the values of A99 at X and Y, then you can plug those in. But if you end up trying to do, and I know we're like out of time. If I try to put these in brackets like it has in there, maybe there's the, yeah, that's the error that we get. So just leave those out of brackets. And we get a nice like contour plot there. Cool. Thanks a lot. You too? Yeah, have a great weekend.